All right, so this is like the third time I've tried to make this video because I wanted to find a way to record it and show you some pictures. So bear with me if I sound a little bit crabby. All right, here we go. So we did these guys in class. We used like factoring, we used some conjugates, we just plugged in. So those are all old things. We did some algebra here, some old things that you could do to do limits. So you can also do these things and some other tricks like L'Hopital's rule and stuff for limits with the kind of limits we're going to do. But realize that some of these things don't work, and so there are some other things we'll have to do. So remember, to prove something continuous, like back last year, your function has to be defined at a certain point. Your limit has to exist at that point, and the limit has to equal whatever the value of the function is at that point. Okay, so those were three rules that had to be true. And you probably had an AP question about it. Okay, so let's get to this piece down here. So when in class today, we went ahead and went over this. And so if you were in class, you can obviously skip over that, but that won't be the important part. But do on the next page, pay close attention to the pictures and things like that. All right, so let's see. So our first move should be to like plug stuff in. So basically what I'm going to be bothered by is if I get a 0 in a denominator. I can't have that. So like down here, put a 1 in, put a 2 in, I'm not going to get a 0. Put a 1 and 2 up here, I'm not going to get a 0, but a 0 in the numerator is fine. This is just a plug-in problem. So if I plug in 1 for x and 2 for y, I get 8 on the top. And on the bottom, if I do the same, plug in 1 here and 2 there, I get 3 plus 4, so I get 7. So done. Nice and easy. Okay. Last year in calculus, I don't know if you remember, but you had a limit that you had to memorize. Limit as x goes to 0 of sine x over x was equal to 1. So the graph of that thing, it kind of like curled up here and it popped up and had a hole right here. And then it came down and like waved back and forth again. But anyway, that height right there was 1. And so the function did not exist at 0, but its limit was 1 because just coming from both sides, the answer was 1. The height was 1. All right, so if I try to plug these things in now, if I put a 0 for x, the top turns into 0, 0 down here, the bottom turns into 0. So 0 over 0, can't do it. I can't do L'Hopital's just now because everything's all mixed together. I can't do L'Hopital's when I have y's and x's together like that. So I am going to do a bit of a trick here that we are allowed to do. Limit of x, y goes to 0, 1, and that is to separate this. Let's separate it into its y's and x's. So I got y over y plus 1 times sine x over x. So this is that same problem, just kind of like spread apart. Okay, well, this guy is right there. So x is going to 0, right? Because my x, this is all my x's, and I'm doing the limit as x goes to 0. So that guy's equal to 1. And this guy is for y is going to 1, so I can just like plug in 1. So I can say that this is 1 over 2, and this guy is 1, so 1/2. Right? So each part, we can spread it into two limits, and if you really want to, you can write the LIM in front of each of these and have a multiplication sign in between, but nobody wants to do that. All right, down here, if I plug in 2's, it's a 0 over 0 situation, so I can't have that. So we are going to factor. All right, so when I factor the numerator, I get y plus 2 and y minus 2. The denominator, I pull out an x, which leaves me with y minus 2. Okay, cancels, and that's the part that was causing me a problem. So now when I plug in my 2's, I get 4 over 2, which is 2. All right, here, same thing happens to me as earlier up here. If I plug in 0 right here, 1 minus cosine of 0 is 1, so 1 minus 1 is 0, and I end up getting a 0 in the denominator as well. So let's separate it, because I do notice it's separable, and leave that x by itself and on the bottom, and then pull the cosine and everything up top. All right, so 1 minus cosine y, that has to stick together, over y squared times 1 over x. So I just separated it out and left, separate the x's and the y's. So we have a limit as x, y goes to 2, 0. So basically, since we've separated it, I know I want this part, the limit as x is going to 2. So I'm confident that that will be 1/2, like that part's done. Okay, this piece. Well, this piece, if I plug 0 in here, I get 0 over 0. So that means we can go ahead and just use L'Hopital's. So if I use L'Hopital's, my derivative of 1 is 0. Derivative of cosine is negative sine, but two negatives make a positive. So I get sine of y over 2y. So here, remember, we're trying to do the limit as we're doing just the y's right here. So y is going to 0. All right, so a couple things you can notice. Look, sine y over y. That's that one. So it's 1. So this part turns into 1. You got a 2 in the bottom. So 1 over 2. So my answer is 1/2 times 1/2, which is 1/4. If you didn't recognize that, you could keep it going with L'Hopital's again, because if you plug 0 in, you get 0 over 0. So derivative of sine is cosine. Derivative of 2y is 2. And you're doing the limit as y goes to 0. So you get 1/2 anyway. So either way you want to do it, you get 1/2 out of that. All right, so those are the easy ones because you can actually like get answers and you're like, oh, I see what's going on. Okay, so let me show you one of these on, what's it called, GeoGebra. All right, so let's get this up here. Oh, GeoGebra, don't be irritating to me. All right, I guess I had, oh, okay, there's one. Oh, no, it doesn't like that either. All right, so let me refresh this. Give me a second. Whenever I move off GeoGebra, it gets mad. It doesn't like me anymore. How long are you staying? I'm making a video right now.
Keeping me on.
I'll be a little bit.
Without me, I want to do anyways.
Okay.
Sadly. I don't want to do this stupid work though.
Lucy, my whole class is hearing you yammer right now.
Oh.
All right, let me see. All right, here we go. So this is what I want. And let's see. So this was the one, the y sine x over x and y plus 1. So this is the one that we were doing. This was part B, right? And so look at, this is like, you know, a crazy picture right here. And so we were trying to do the limit as xy goes to 0, 1. Well, we found that it was 1/2, right? So I put that point on here. So look at that point. So there it is. That point was actually on the graph itself, and I think you can probably see that it's on there. So that's why we got 1/2, okay? Now, what if we had tried to do it like right in the middle here, or right here at -1? That would have been something else, right? So, but luckily we didn't have that. So that's just like a normal occurrence right there, okay? So that was that one. So let's look at the next one that we're trying to do. The next one that we're trying to do is going to be x plus 2y over x minus 2y. So let's take a look at that picture. So let me turn these off. All right, so this graph right here. So it's kind of crazy, right? There's like a weird twisty thing going on there. So just know that that's what the picture is looking like. All right, our x-axis is our red axis and y is the green. Okay, and we are going to be doing this at 0, 0. So we're going to have to approach this in a little bit of a different way than before. There's nothing that I can do with this problem to simplify it. I can't factor it. I can't separate the x's from the y's. There's just like nothing to do. So let me show you what we have to go and do then. Okay, so here we go. So it's not so easy when we can't do those little tricks we did on the last page, right? Recall from last year that when you do a limit, your limits has to match from the left side and the right side. Okay, So what happened is that, you doing a problem, you have from the left and you come from the right, and when they don't match, you say does not exist, right? Another reason that a limit wouldn't exist is when something would, kind of like with a trig function, it would come and it would like oscillate, and it would come from this way and oscillate, and it was just bouncing, 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 and that was also a does not exist, right? When you had kind of like an oscillation there. And so we're going to see that a little bit later. All right, so let's get back to here. So we not only have to approach from the left and the right, we have to approach from any direction possible. So down at the bottom of the page here, these are the things we're going to be testing. X equals 0, y equals 0, y equals x, y equals x squared, and x equals y squared. So if you test those 5 things and you don't get a mismatch, then you're done. Okay? So what we're going to do here, so we can't just come from the left and the right, we have to come from any direction. So what we're trying to do is we're trying to move along a certain plane. You can think of a line or whatever, but we're going to move along a plane and we're going to come to this function, and the limit has to be the same along that plane as it does along any other plane. And so instead of coming from a direction, left and right, we're moving along a plane, and I'll show you in a second on the pictures what I mean. So what we're going to do is we're going to move along the plane of x equals 0. So we're going to let x be 0, okay? So if I let x be 0 in this problem, that means that that's 0 and that's 0. And then I only have to worry about the y's. So I have my limit of y going to 0, and I have now let all these x's be 0. So I have 2y over negative 2y. So when I do that, these cancel out to a negative 1. So I have my limit as y is going to 0 of negative 1, and that would just be negative 1. So now if I do it along the plane of y equals 0, well, then I would have the limit as x goes to 0, so I still have x going to 0, but I'm letting these y's go to 0, and have x over x. Well, this equals 1, right? Because these things cancel out to 1, so my limit as x goes to 0 of 1 is 1. So this is bad, right? I got a mismatch. One time it was negative 1, the other time it was positive 1. And so this limit does not exist because we had a mismatch. So along different curves or different directions per se, my answer was different. So let me see if I can show you and explain that to you on the picture here. All right, so let me go back to my picture. Hopefully GeoGebra didn't die again. Okay. Dang it, GeoGebra. All right, give me a second. Okay. All right, so here's our problem right here. And we're going to look at, we did x equals 0. So that's a plane. So let me turn this around and like show you, I need to turn it this way. So look, when you approach x equals 0, this plane right here, the left side comes to the number negative 1, and the right side comes to the number negative 1. So that's along the curve x equals 0. So that's that plane and that purple thing intersecting. Well, instead, why don't we do y equals 0? Okay. Now y equals 0, if I turn it the other way, look at what happens. Y equals 0 intersects the curve at positive 1 and positive 1 here. So it was like 2 different places. I chose to come from 2 different directions. I came along one plane and it came to 1. And when I came on the other plane, it came to negative 1. So you see what's happening here is that it's either coming down to negative 1 or positive 1. It doesn't match. It's not coming to the same place from any direction. So, I mean, that's the best I have to kind of like show you like what I'm talking about. But so you're gonna have to take it at that. But basically they don't match, okay? All right, so let's see if we can get like one more done right here. So let's do this one. And so usually a lot of these problems, they don't exist, let me tell you that. So let's try this one. X equals 0 and y equals 0. Those are my first 2 easy ones. Well, when I notice, if I let x or y be 0, the top just turns into 0. So I would get like 0 over x squared If I let y be 0, I would get 0 over y to the 4th if I let x be 0. So basically, both of these would be just be the limit of 0, and those are equal to 0. So those match at 0, right? So let's do y equals x, because remember we have these 5 down here that we're going to try. All right, so if y was equal to x, so I'm going to let all the y's turn into x's. So all I care about is this x right now, limit as x goes to 0. So all my y's are turning into x's. So I have x times x squared, so that's x to the 3rd. I have x squared plus x to the 4th. Okay, so if I go ahead and try to plug in 0 right now, I get 0 over 0, so I can do L'Hopital's. So I'm going to get 0 over 0, so I say, hey, let's do L'Hopital's rule. Okay, so my derivative up top is 3x squared. On the bottom, I'll get 2x plus 4x to the 3rd. Okay, so that's going to be 0 over 0 again. So again, I'll do L'Hopital's. So when I do it this time, I get 6x over, this turns into 2, and then over here I get 12x squared. So if I was doing the limit of that, the limit as x goes to 0, well, now I have a problem. I have 0 on top and a 2 on bottom. Well, 0 over 2 is 0. So you're like, oh, everything's looking good. So let's try another one. So let's try y equals x squared. So all the y's are turning into x squareds. So I have my limit as x goes to 0. This y is an x squared. So I have an x, and I have x squared squared. So that's x to the 4th and x, so it'd be x to the 5th. On the bottom, that x squared staying, and then I have an x squared to the 4th power, so that would be plus x to the 8th. Now, hopefully you can see that similar thing is going to happen to me here. I would keep doing my L'Hopital's rule. The top would keep turning into a new derivative, but eventually this will be turning into another 2, kind of like this one did here and here. So eventually the top is going to still be an x in it, and then the bottom is going to be a 2. So hopefully you can kind of like see how we did it here and see, oh, I'm going to get 0 over 2 eventually, so I'm going to get 0. Okay? All right, now the last one. Let's do x equals y squared. So x equals y squared means I'm going to, all the x's are now y squared. So I have my limit as y goes to 0. All my x's are y squared. So I have y squared times y squared, so y to the 4th. On the bottom, all my x's are y squared. So y squared squared is y to the 4th. And I have another y to the 4th that I don't change. So look at that. I have y to the 4th over 2y to the 4th. So I really have these cancel out. So I really have the limit as y goes to 0 of 1/2. And that is 1/2. And that right there is a mismatch. Everything else was 0. I was looking good, but that's a mismatch. All right, so let me just show you the picture of this and you can see maybe why that happened. Oh, GeoGebra, don't fail me. I think, dang it, every time I go off GeoGebra, it like messes up. All right, go away. All right, it'll be quick. All right, so let me turn these off. And the reason, I don't have a big reason here for you, but the reason here is that, I don't know if you can see it, but do you see that how it's oscillating? You see how it's like flip-flopping back and forth in the middle? So it's going up and then it's going down. It's going back and forth between like these two heights. I think you can see the ridges a little bit, but that's why this thing doesn't exist, because it's like at any particular moment you might be at a high point and then the very next second you're at the low point, and so it's like all over the place, and so it's oscillating, and so that's why the limit doesn't exist there at the center. Okay, all right, so your job tonight is to have these notes done and then finish 15.1, the bookwork. I'll see you in class.